Every August, the same thing happens over the Atlantic Ocean. Tropical waves rolling off the coast of Africa start arriving bigger, more frequent, and more organized, right on schedule, exactly as meteorologists expect, heading into the season's historic peak, a ramp-up that has repeated itself with remarkable consistency across decades of satellite records. This year, that part of the pattern held up perfectly. And yet, somehow, this is shaping up to be one of the quietest Atlantic hurricane seasons in nearly 40 years. Understanding that contradiction tells you almost everything you need to know about what is actually happening in the tropics right now. To understand why August behaves so differently from earlier summer months, you first need to understand what a tropical wave actually is. These are areas of low pressure that form over the African continent and drift westward into the Atlantic basin, arriving without any closed circulation of their own, essentially disorganized clusters of thunderstorms and disturbed weather rather than anything resembling a storm. According to the National Hurricane Center, roughly 60 of these tropical waves track across the Atlantic in a typical year, and about 1 in 5 of them eventually organizes into a tropical cyclone. Several factors converge every August to make that transformation more likely than it was just a month earlier. Tropical wave activity itself increases as the season progresses, more disturbances rolling off Africa with greater regularity. At the same time, the hot, dry, dust-laden air that regularly blows off the Sahara Desert and squelches tropical development throughout early summer begins to decrease, in part because the tropical waves themselves feed moisture back into that dry air and disrupt the dust transport that would otherwise choke off developing storms. Atmospheric instability increases as well, meaning the air becomes more willing to support the kind of sustained thunderstorm activity a wave needs to organize into something more dangerous. A combination of factors meteorologists have documented repeating with remarkable consistency across nearly every August on record. By every one of those measures, this August has behaved exactly as expected. Satellite. Imagery has shown 2 separate Cabo Verde waves, named for the island chain they typically pass near as they exit Africa, moving steadily westward with long, uncertain roads ahead of them. The National Hurricane Center has been actively tracking multiple disturbances at once, including one system designated Invest 92L that briefly carried as much as a 70% chance of developing within a week. Numerous tropical waves have continued streaming off the African coast into the basin's main development region, the stretch of ocean between Africa and the Caribbean, where the majority of the season's most powerful hurricanes typically originate. And yet, despite all of that raw material arriving essentially on schedule, the 2026 Atlantic hurricane season has produced only 3 named storms through late August, with a combined active lifespan of just 4.5 days between them, an almost startling figure once you consider how many separate waves have already crossed the basin this summer. Tropical storm Arthur formed in mid-June, and while it did bring flooding to parts of the Deep South, most of that damage actually occurred after the storm had already weakened into a remnant low, rather than while it was still an organized named system. Tropical storm Bertha followed about a month later, hugging the Gulf Coast and delivering only locally heavy rain to a handful of areas. Tropical storm Cristobal formed in the middle of the Atlantic in mid-August and lasted barely 24 hours before falling apart entirely. 2 additional tropical waves last week came close enough to becoming tropical depressions that forecasters had the next 2 names on the list, Dolly and Edward, ready and waiting. Both waves were torn apart instead, shredded by a combination of wind shear and dry air before either one could organize into anything resembling a genuine tropical cyclone, another entry on this season's growing list of near misses that never quite crossed the threshold. Here is the specific number that captures just how unusual this season has become. Meteorologists measure overall hurricane season activity using something called accumulated cyclone energy, or AC, a metrito. CC that accounts not just for how many storms form, but how long each one lasts and how strong it becomes while doing so. By that measurement, this is the slowest start to any Atlantic hurricane season since 1988. Going back through the entire satellite era, which stretches to 1966, only 4 hurricane seasons have ever started slower by this point in the calendar in 1988, 1984, 1977, and 1967, a genuinely short list that puts this year's suppression into sharp historical perspective. So why are all these tropical waves arriving right on their usual August schedule, failing to develop into anything more than brief, weak systems? The answer traces back almost entirely to a single dominant atmospheric force sitting thousands of miles away in the Pacific Ocean. A rapidly intensifying El Niño has been building all year, and stronger El Niño events reliably increase wind shear, meaning winds that change speed and direction with height across the Atlantic basin. That increased shear acts almost like a set of invisible scissors, tearing apart the vertical structure a tropical wave needs to organize into a closed circulation before it ever gets the chance, or weakening any storm that manages to briefly form despite the hostile environment around it. NOAA's own lead hurricane season forecaster has been direct about just how dominant this single factor has become this year, noting that once El Niño fully emerges, it typically becomes the overriding influence on total season activity, more powerful than any of the other, usually more discussed ingredients like sea surface temperature or the strength of the West African monsoon. And this particular El Niño has continued strengthening with every passing month, which helps explain why the suppression effect has only grown more pronounced as the season has worn on, rather than easing up the way a milder event might have, leaving forecasters watching for the moment that dominant influence might finally begin to loosen its grip. This is not entirely unprecedented territory, and looking back at the last comparably quiet season offers a genuinely useful, if slightly unsettling, preview of what might still be ahead. The 2022 Atlantic hurricane season went the entire month of August without producing a single named storm, something that had only happened once before since satellites began reliably tracking the basin during the sharply strengthening El Niño of 1997. But 2022 pivoted hard and fast once the calendar flipped to September, ultimately producing Hurricane Ian, which caused catastrophic damage across Florida, along with Hurricane Nicole and Hurricane Fiona, which went on to devastate parts of Atlantic Canada as an intense post-tropical storm. The parallel between that season and this one is not perfect, and forecasters are careful to note the differences rather than treating history as a guaranteed rerun. The El Niño driving this year's suppression has continued strengthening at a faster pace than the one present in 2022. Which could mean the shear-driven quiet persists even further into the season before easing, or it could simply mean the eventual pivot, if one comes at all, arrives, later and more abruptly than it did back then. Either way, the 2022 comparison serves as a genuine reminder that a historically quiet start carries no guarantee about how the season's back half will ultimately unfold. That history matters enormously for anyone tempted to fully relax simply because named storms have been scarce so far this year. September remains the Atlantic's historical peak for a very specific reason: sea surface. Temperatures reach their warmest point of the entire year right around then, and the broader atmospheric conditions that support tropical development tend to become most favorable during that same stretch. Even during previous strong El Niño years, hurricane activity in September never dropped to zero. It simply dropped to roughly one hurricane per year on average across the historical record of comparable seasons, a real but meaningfully reduced level of activity rather than a complete shutdown. There's also a longer-running trend layered underneath this single quiet season that researchers say deserves attention, regardless of how any individual year turns out. Climate researchers, tracking Atlantic hurricane behavior over recent decades, have documented a measurable increase in the fraction of tropical cyclones that undergo rapid intensification, a dangerous process where a storm's maximum sustained winds increase by at least 30 knots within just 24 hours. From 1980 through 2025, 190 Atlantic tropical cyclones underwent this kind of rapid intensification, and nearly a quarter of those did so at what researchers classify as an extreme rate. Warmer ocean water provides more of the raw fuel a storm needs to intensify explosively, which means that even in a season where far fewer storms manage to form in the first place, any storm that does find a genuine gap in the wind shear carries a measurably higher risk of strengthening dramatically and rapidly once it gets that chance. Tropical cyclone rainfall rates have followed a similar trajectory, climbing measurably both globally and specifically within the Atlantic basin as ocean temperatures continue warming, with researchers projecting further increases as that warming continues in the years ahead. That detail matters because a storm's destructive potential is never captured by wind speed alone. Some of the costliest and deadliest Atlantic storms in recent memory, including systems that never even reached major hurricane strength, caused the bulk of their damage through catastrophic, slow-moving rainfall rather than through wind. A pattern scientists expect to become an even larger share of the overall threat picture as the climate continues to warm. That is precisely the scenario meteorologists keep warning people not to lose sight of during a quiet stretch like this one. A suppressed overall season does not mean the individual ingredients capable of producing a dangerous storm have disappeared. Its simple why means those ingredients are currently struggling to align in the same place at the same time. Should a wave manage to find a temporary pocket of favorable conditions, perhaps a brief lull in the wind shear or an unusually warm patch of ocean? A named storm can develop with very little advance warning, and if that development happens close to land rather than far out at sea, coastal residents would have considerably less time to prepare than they might assume based on how the season has unfolded so far. The practical guidance from forecasters tracking this exact dynamic stays consistent regardless of how quiet any individual season looks on paper. Coastal residents are urged to have an evacuation plan, emergency supplies, and important documents ready well before any storm actually appears on a forecast map, precisely because the gap between a wave sitting harmlessly offshore and a rapidly strengthening named storm bearing down on a coastline can sometimes be measured in a matter of days rather than the week or more people might assume they have. It only takes one destructive landfall, or even a slower moving, flood-producing tropical storm well short of hurricane strength, to make an otherwise historically quiet season memorable for entirely the wrong reasons. If you want to understand exactly what's actually happening beneath the surface of a quiet hurricane season, and why the waves themselves tell a very different story than the named storm count does, make sure you like and subscribe, because this channel breaks down exactly what the tropical data shows before the next system makes headlines, so you're never relying on the storm count alone to gauge the real risk. So where does this actually leave the Atlantic right now, heading into the final stretch before the season's historical peak? The raw ingredients are behaving exactly as meteorologists expect for late August. More waves, less dust, rising instability, arriving right on their usual seasonal schedule. What is missing is the one factor no forecaster can simply wait out: a break in the intensifying El Niño's wind shear, substantial enough to let one of those waves actually organize before it gets torn apart. Whether that break arrives in the final days of August, sometime during September's historical peak, or not at all this year, the tropical waves themselves are not the story anymore. The real story is the invisible battle playing out overhead between every wave rolling off Africa and the shear working to unravel it. And right now, across nearly the entire basin, the shear is still winning, even as the raw material for the season's next chapter keeps arriving right on schedule.